everyone. Well, hello and welcome to tonight's Ask the Expert webinar hosted by the Melanoma Research Foundation. My name is Caroline Glavin, Education Program Manager for the Rare Melanoma subtypes here at the MRF. And we are so glad you are joining us for this important discussion on mucosal melanoma, current and emerging treatments, research, and patient perspectives. As many of you know, mucosal melanoma is one of the rarest and most complex forms of melanoma, and tonight we'll explore both the latest research and the lived experiences of those affected. We're joined tonight by Dr. Kasey Couts, whose work focuses on advancing therapeutic strategies for rare melanoma subtypes, and Toni English, a mucosal melanoma survivor and patient advocate. Together, they'll share insights into current treatments, emerging research, and what progress looks like for this community. Please stay with us until the end for a Q&A session where Dr. Couts and Toni will answer questions submitted by our community. And feel free to, as we go along, add your questions into the Q&A section if any come up. All right. Okay, can everybody see my next slide? I think it's working. So before we get started, I wanted to take a moment and share a little bit about the Melanoma Research Foundation, or the MRF, as I have called it. The MRF is the largest independent organization devoted to melanoma. Our work is grounded in three core pillars: education, advocacy, and research, all aimed at improving outcomes for patients and families. We're dedicated to advancing medical research, raising awareness, and ultimately finding a cure for melanoma. At the MRF, we know that education empowers patients and families to make informed care decisions. We offer free resources for patients, caregivers, and providers, available to download or order for free to any clinics, schools, or community events nationwide. We're proud to introduce our new mucosal melanoma patient pamphlet, Know the Signs, Know the Support, featuring key information and symptoms, treatment options, and resources, as you see over here to the left on my screen. The MRF also hosts in-person symposia with leading medical cancer centers nationwide. Recordings of our recent events are available on our YouTube channel, and new programs are coming this fall in Santa Monica, Houston, and Miami. You can explore even more on-demand education, including animated patient videos. We have 6 available, 2 in production, Ask the Expert webinars, as you are here tonight at one of those, patient testimonials, which are all available at any time at melanoma.org or on our YouTube channel. Advocacy is the MRF's second pillar, empowering patients and caregivers to make their voices heard. Every year, we bring members of our community to Capitol Hill in DC to meet with congressional leaders and advocate for increased cancer, specifically melanoma research funding. And we're happy to share the save the date for our 2026 Hill Day, or Advocacy Day. It will be March 1st through the 3rd. And we'd love to have you there. And if you're interested in partaking, please feel free to reach out to us at education@melanoma.org. And we will be sending a follow-up email after tonight's session, including that email address. So feel free to just send us a note if you're interested. And our third pillar, research, it is at the heart of our mission, supporting scientists whose discoveries lead to better treatments, improved outcomes, and new hope for melanoma patients. This slide highlights some of our groundbreaking research that the MRF has funded in the past and continues to support today. And if you are ever interested in learning a little bit more, we do have a designated research tab within our website, and this QR code will bring you right there. So I'll give you a second on this if anybody's interested. Again, our website is melanoma.org. We have a variety of patient and caregiver supportive services, such as our patient and community forum. We have a treatment center finder, financial assistant resources, and something that I think kind of puts us aside of a lot of other resources. We do have an Ask a Nurse hotline, and she is an oncology certified nurse and available really at your fingertips. So you can either call or email. Her name is Whitney, and she's just a wonderful resource. Obviously can't really give any medical advice, but can point you in the right direction. Or if you have questions and just need things answered, a really, really great resource there. And as I mentioned, our clinical trial finder, the MRF is proud to offer this resource. As I mentioned, it's an invaluable tool that connects patients with trials tailored to their specific diagnosis, ensuring they receive the most up-to-date care options available. Again, this is also within our website under the patient care tab. And what's great about this resource is you can request a navigator to talk you through the process of clinical trials. We're fortunate in the US to have many clinical trials, but it can be overwhelming. So this is a great resource to kind of help you navigate that and have a partner along the way. And there are many opportunities to support the work of the MRF through a variety of programs, events, and research funding. We host events such as our patient symposias, as I mentioned, and our Miles for Melanoma 5K and 1 Mile Walk in cities all across the country. And we really hope that you can find us in your city and join us at one of these wonderful events. And if you're interested, again, reach out to education@melanoma.org to learn more about ways you can stay engaged in the melanoma community while investing in our shared mission. And this is we have a monthly newsletter called Spotlight, and it really gives updates of kind of what we're doing in the advocacy, research, and education space. It's a great way to stay up to date with the MRF. So again, feel free to scan this QR code. There is also a link on our website, and you can just fill all of your information in, and it'll send it to us, and then you'll be right in our newsletter distribution list. But feel free to sign this QR code here if you're interested in signing up. And I will give a minute there. Alrighty, and then again, lastly, the best way to learn more about the MRF, including information on education, advocacy, and research, as well as our awareness campaigns or upcoming events, is to follow us on our social media accounts. These are all of our accounts here. All of them typically are either a Cure Melanoma or LinkedIn Melanoma Research Foundation, as well as Facebook. But we'd love to stay connected with you. And, during our campaigns as well, we'd love to hear about your story. We have an Out of the Shadows campaign for mucosal melanoma. So when that comes around, we would love to hear your stories and hear from you directly. And lastly, to learn more, as I mentioned, feel free to go to our website at melanoma.org to learn more. All right, and now just a little bit of housekeeping before we jump into it here. Let me just move this over. All my screens are messing around here, but here we go. But before we get started, just as I mentioned, a little bit of housekeeping. Please feel free to use that Q&A box to share your questions during the session. And the information tonight is really just educational. No personal treatment questions. If you have any of those, we do advise that you connect with your healthcare provider. And at the end of the program, a short survey will pop up right after the Zoom ends. And really, your feedback is so valuable to us in shaping these future programs. We really love to keep the patient's voice at the center of all the work that we do. So we'd love to hear from you and anything that you would like to see in our Ask the Experts series. And now I'd love to take the opportunity to introduce Dr. Kasey Couts, a research scientist and assistant professor who serves as co-director of the CU Center for Rare Melanomas at the University of Colorado. Her work focuses on understanding the biology of rare melanoma subtypes and developing new therapeutic strategies to improve outcomes for patients. This evening, Dr. Couts will share insights from the research side, highlighting current and emerging treatments for mucosal melanoma, progress being made in the lab and clinical space, and what these advances could mean for the future of care. So I will go ahead and hand it over to Dr. Couts.
Thank you, Caroline, for the introduction, and just thanks to the MRF for inviting me to be here. I think this is a really neat opportunity to just have sort of a less formal, just kind of chat about mucosal melanoma, and I'm just really excited to be here and share my perspective from kind of a more research side, science, what's going on. So let me share my talk here. Okay, so as Caroline mentioned, I'm an assistant professor. I'm at the University of Colorado at the Anschutz Medical Campus. So I've been studying melanoma for about 20 years. So back when I first started my PhD studies, I got into basic melanoma research. And then about 10 years ago, when I joined the Division of Medical Oncology at this campus, I really got interested in focusing and learning more about these rare melanomas. And I really become passionate about mucosal melanoma specifically. And so I'm really excited to be here and kind of just give you an overview kind of from a little bit more science background of the science underlying the treatments and what we're kind of trying to do from the research side to really better understand and treat mucosal melanoma. It's pretty simple. I'm going to talk a little bit. First, I just want to go over what is mucosal melanoma. I think, sometimes people, it's really not clear, like, how did I get the skin cancer in my nose or in my vaginal canal? This doesn't make sense. And so I just want to talk about a few slides on what is mucosal melanoma, really where does it come from? Then I'm just going to give sort of a high level overview of some of the current treatments and trials that are going on, focusing on both sort of targeted therapies and then immune-based therapies. And then I just have like 2 or 3 slides at the end talking about some of the ongoing research, what kind of some questions in the field that we're trying to address are, and also what are some of the tools that we have to actually do research and study mucosal melanoma, and how we're really trying to work as a community to develop better tools and really advance the research better. Okay, so what is mucosal melanoma? So I just want to start a little bit with just a broad overview of what is cancer. And so, all of our tissues in our body are made up of these individual cells. And normal cells do grow and divide as part of their normal function in order to generate and regenerate healthy tissues. However, sometimes these normal cells can actually undergo these genetic changes, mutations, pick up alterations either through the environmental toxins, exposures, or just from normal division processes. Sometimes cells mess up. And so what happens is, upon getting certain genetic changes, cells can really start growing uncontrolled, leading to tumors. And in the case of melanoma, these normal cells that are where the cancer is coming from are called melanocytes. And I'll go into them a little bit more in the next slide. And essentially, these are sort of the normal cells that start growing out of control and really end up becoming the melanoma tumors. So melanocytes are kind of most famously known for their role of being the pigment producing cells in the skin. So in response to stress or ultraviolet light, these melanocyte cells actually produce this melanin particles that they then secrete into the surrounding environment. And so on the right here, you can see the melanocyte cells are located, these brown cells, kind of in the dermal epidermal junction of the skin. And they secrete this melanin, and other cells around them, like keratinocytes and other cells, they just kind of are able to take up this melanin, and then they're also protected from sort of this UV induced damage. However, again, upon getting certain changes, these can start growing uncontrollably in the skin, and then that leads to what we know as cutaneous melanoma. However, I think what some people don't realize is melanocytes are actually located throughout the body, and they have a lot of other functions other than just producing melanin. They're located in a lot of what we call barrier tissues, so tissues that are sort of at the junction between the internal environment and the external environment. And you can imagine, even up in like the vaginal canal, you're still at sort of this junction of, the internal environment and some exposure to the external environment. And so a lot of their functions are immune related and trying to fight off these pathogens and other things that are in the surrounding environment. But essentially, melanomas can develop anywhere that there's a melanocyte. And so this really leads to diverse places where melanomas are able to develop. So while they're able to develop anywhere, as you know, the most common place is the skin. And so about 90% of melanomas are going to be cutaneous melanomas. However, about 10% occur on some other sites, and we kind of classify these together as sort of rare melanomas. And we say rare melanomas, but these are actually about 10% of all melanomas. And so 1 out of every 10 patients that comes into the melanoma clinic is going to have one of these rare subtypes. And so, so we call it rare, but as a whole, these actually make up a pretty significant population of the overall malignant cases of melanoma that we see. So acromelanoma is a type of melanoma that occurs on non-hair-bearing skin. And so that is mostly the palms of the hand, the soles of the feet, or underneath the fingernails and the toenails. That makes up about 3%. Uveal melanoma makes up about 5%. And it can sort of originate in different structures within the eye, but it all really originates within the eye. It does have a propensity to metastasize to the liver. So it can be very aggressive, but not all cases do. And then finally, mucosal melanoma. So here I'm showing just a representative nasal melanoma. Really, mucosal melanoma is the rarest of the rare. It's less than about 1.3% of all melanoma cases. And, one of the unfortunate things about the mucosal melanoma is due to their anatomic location, they're often not detected until a little bit later on. And so it's usually the tumors are a little bit more advanced. The tumors are larger and have potentially spread to lymph nodes by the time that you realize that they're even there, compared to the other melanomas on the skin or in the eye that are pretty easy to see. So this is just overall, just a rough number, 5-year survival. And you can see, compared to the other subtypes from the initial diagnosis, the outlook for mucosal melanoma is unfortunately not as good as the other melanoma subtypes. So where do these occur? So again, I mentioned they can occur all over the body. We've even had cases in the inner ear canal and the mucosal tissues there. But really the main location is the head and neck, and then genitourinary region. So head and neck melanomas mostly occur either in the mouth, but I feel like we more commonly see the nasal sinus passage melanomas. But here's an example in the mouth. They can occur in the hard palate, they can occur on the gums, so lots of different locations in the mouth. And then they can occur either in the nose or up farther in the actual sinus passages. And so overall, between men and women, these are the most common. However, within women, vulvovaginal melanomas are actually the most common site for it to occur in women. And we call it vulvovaginal because it can occur both up in the vaginal canal itself, or it can occur more on the vulvar surface, which is the external kind of surface that's still mucosal. So the inner labia, the clitoris. So they can also occur in those vulvar regions that are still mucosal, but they're not up in the vaginal canal. And this is important because there's actually, I'll show I think the next slide, there's actually differences in survival rates and other things between whether it's located in the vaginal canal or whether it is on this external sort of vulvar surface. And then finally, anorectal melanomas, they can be located in the anus, closer to the skin. So sometimes these can borderline what we call perianal, but sometimes the perianal is a little bit more external and actually on a skin surface. So those are classified as cutaneous. But the anorectal melanomas can occur in the anus itself or further up within the rectum and the canal. So I think there's one of the preliminary questions was about prognosis. So I just pulled this table from a review that a group of us put together, this review paper based on a conference or a meeting, a workshop that the MRF sponsored a couple of years ago. And so you can see the median overall survival from diagnosis. So for the head and neck is around 52 months, and for the vulvar melanoma is also around 53 months. However, for the anorectal melanomas and vulvovaginal melanomas, the survival from diagnosis is it's significantly less. And then correspondingly, we see better overall survival rates, 5-year survival rates for head and neck and the vulvar melanomas. And again, not quite as good for anorectal and vaginal melanomas. And we still really aren't fully sure for the reasons underlying the difference in the disease progression and survival. Okay, so now that I kind of just introduced the different types of mucosal melanoma and describe what it is, I'm going to hop into looking at what some of our current treatments are. So just broadly, when we think of any cancer, really in general, there's kind of a few main categories of different types of treatments. So one are general treatments. So first of all, surgery. So you can see here for a cutaneous melanoma that's really small, typically these are very easy to excise and treat with surgery. However, you've seen some of those pictures of some of the primary melanoma, mucosal melanomas. A lot of times these are not able to be fully resected by surgery. So that's definitely a challenge. Also, while there are cases and case reports of mucosal melanoma and cutaneous melanoma responding to radiation and chemotherapy, usually these are not super effective options across melanoma in general. So even in cutaneous melanoma, chemotherapies and radiation don't work as well as, say, other cancers like breast cancers. There's certain subtypes of breast cancer that respond really well to chemotherapy and radiation, esophageal cancer. So there's a lot of other, cancers that respond well to these treatments, but they're just usually not quite as effective for melanoma in general, and particularly mucosal melanoma. So another category of treatments that we call targeted treatments are a group of drugs that are designed to target a specific outcome of a mutation that you have in the tumor itself. So really we're targeting a certain feature that's driving the tumor. And so these can be gene mutations. These can be something that we call gene fusions. And usually these are very fast acting treatments. Usually the tumor, if it responds, it shrinks right away. You usually get a really good response. However, compared to some of the immune-based treatments that we'll talk about, these typically tend to not be as durable or as long-lasting. So these targeted treatments, the tumors, we don't kill off the entire tumor, and sometimes you can actually, these few remaining cells sit there and they're able to adapt to the drug and become resistant. And so while these still are a really effective treatment option and play a major role in, I think, how we treat patients today, they're not quite as durable. And so I think because of that, really the emergence of immune treatments over the last decade or decade and a half has really been where a lot of the big breakthroughs have come, mostly because when you have a response to these immune treatments, they are lasting and they are durable. And so a couple types of immune treatments we have are immune checkpoint inhibitors, and then the more recently emerged TIL therapy. So I'm going to go through just a few of the main targeted treatments for mucosal melanomas first, and then I'll focus on the immune treatments after that. Okay, so I'm going to show some kind of busy pie charts, but what we're really looking at here is just the distribution of what we call driver mutations. And so in cancer, as I mentioned in that very first slide, a lot of times these cancers, they pick up a certain genetic change that really sparks them and really enables them to drive and become cancerous. And we call these kind of founding events driver mutations. And because they're really the fundamental mutation that kind of initiated the cancer in the first place, a lot of times the cancers are really dependent on that mutation in order to be able to keep growing and survive. So a lot of times these what we call driver mutations are really good for targeting with drugs, because if you can block them, usually the tumor being dependent on them will respond, and you can, you can shrink tumors and eliminate tumors using these targeted therapies. So back around 2002, it was discovered that about half of cutaneous melanomas have a mutation in the gene called BRAF. And since then, companies have developed numerous drugs to target this BRAF, and I'll talk a little bit more about what this gene and protein is in the next slide. And so by successfully combining these RAF inhibitors with another inhibitor of a protein just downstream of RAF, this has actually resulted in a really great treatment option for melanoma patients. And it was really one of the biggest breakthroughs in just cutaneous melanoma treatment, given that it doesn't respond to chemotherapy and so many other sort of general treatment options. So then we have acral and mucosal melanoma. And I wanted to put acral up here side by side just to kind of give you an idea, because if you kind of just broadly step back and look, they have really similar genetic profiles between these acral and mucosal melanomas. So you can see BRAF, this gray section, is much less smaller and is a lot smaller in acral melanomas. Only about 10% of acral melanoma have this BRAF. And really, it's very, very rare, very uncommon to see this BRAF mutation in mucosal melanoma. So whereas, cutaneous melanoma patients, if they don't respond to immune therapy, they kind of have this BRAF to fall back on half of the time. This really is not a treatment option that is available to mucosal melanoma patients. Instead, about 40% are driven by alterations in a different gene called RAS. So there's NRAS, there's KRAS and HRAS, there's a couple sort of flavors of RAS, but about 40% are driven by RAS. And I'll talk a little bit more on the next slide about actually what RAS is. And so, so this is a really big opportunity that if we could come up with a good treatment against RAS in these melanomas, that could really open up treatment options for a pretty wide range of patients. And then just as an example to throw it up here for comparison, you can see uveal melanomas have a totally different driver landscape. So they're driven by alterations in these GNAQ and GNA11, GNAQ and proteins. So what is this RAF and what are these RAS molecules? So basically they're part of what we call the MAP kinase signaling cascade. And these signaling cascades exist in cells in a way to sort of relay what's happening in the cell's environment and get that signal translated into the cell so the cell knows how to respond functionally to that stimulus on the outside. And so here we have depicted, you can see this is the exterior of the cell up top. We have these little signals, these little molecules kind of floating around that can bind certain receptors on the cell surface that can then translate the signal through the signaling cascade all the way down until eventually it leads to a certain functional response. And this MAP kinase pathway in particular is the pathway in cells that drives proliferation and growth. And so it's a very commonly hijacked pathway by cancers to promote growth, is to have mutations that sort of activate this signaling cascade. And so here you can see kind of where RAS and RAF sit in this cascade. So RAS kind of sits at the top and it can activate RAF. And then that activates these MEK and ERK and these downstream proteins. And now, as I mentioned, there's quite a few inhibitors that have been developed against RAF and also this downstream target MEK. And so one of the most common combinations is this vemurafenib and cobimetinib to combine the inhibitors of these two proteins to treat patients that have a RAF mutation. So essentially what happens when patients have a RAF mutation, the signal is just always turned on and it no longer depends on these outside signals in order for the pathway to get turned on or off. And so basically it's just like the gas pedal is always on. And so RAS sits just upstream of that. And RAS is a little bit different of a molecule. It's not what we call a kinase. It's a different type of protein. And based on its structure, it's been really hard clinically to actually develop drugs against RAS. It was kind of considered sort of this undruggable target. However, in the recent years, there's a company, Revolution Medicines, and some others that have really come up with a new way of kind of targeting this RAS molecule. So one of the ways that it targets this RAS molecule is, here's the drug here. And so this little orange molecule. So what it does is it goes and it binds this protein called cyclophilin A. Now, cyclophilin A is a substrate for RAS. So normally RAS would bind it and activate it, but it's not an oncogenic substrate. So essentially when RAS binds this other substrate, it gets stuck to the substrate, but not the substrate that causes the cancer to grow. So basically it's causing the RAS to sort of be sequestered or bound up so that it can't have its oncogenic function anymore. And so here's just a little bit of data. This is from our lab. So these are a couple of cutaneous melanoma cell lines. And I know this is probably looks not very familiar to you, but what's happening is basically on the x-axis, we're treating the cells. These are cell lines, cutaneous melanoma cell lines, and these have RAF mutations, not RAS. We're treating them with increasing concentrations of this RAS inhibitor. And on the y-axis, we're measuring viability, or how many cells are still alive. So we want to kill the cells and we want it to go down. Now, these have RAF mutations, not RAS. So we don't expect the drug to work here. And that's kind of what we see. You can see that the tumor curves aren't going down. However, when we look at treating a cutaneous melanoma NRAS cell line, you can now see that this tumor curve is going down. And as we increase concentration of drug, we're starting to kill the cells. So we've also looked at this in acral melanoma RAS cell line, and we also see a similar curve. And when we look at this in a mucosal melanoma cell line, you might be able to see that the curve actually drops off even faster. So what we're seeing is this mucosal melanoma cell line is more sensitive to this RAS inhibitor than even the cutaneous or the acral cell line that we tested. So it's kind of a nice change for once that a cutaneous melanoma treatment actually is working better in a mucosal model, not worse. And so So this is part, right now, they do have an ongoing clinical trial. This is a really large clinical trial encompassing a lot of different solid tumors that have a mutation in this RAS protein. So another targeted therapy option is this protein KIT. So you can see it's in a very small percent, like 3% of cutaneous melanomas, but about 10 to 15% of mucosal and acral melanomas have this KIT. So what is KIT? So KIT is actually a kinase receptor that's sitting on the surface. And so by it getting mutated and activated, it's activating RAS in the whole pathway. And there's actually a few different FDA-approved KIT inhibitors. So they're not specifically approved for mucosal melanoma, but they can be used off-label. And in mucosal melanomas that have a KIT mutation, the overall response rate is approaching 40%. So that's pretty good. It is dependent on the certain location within the KIT gene. But overall, like this is, there's a lot of good case studies and good reports of patients having good responses to KIT inhibitors. So finally, the last targeted therapy I want to talk about is thinking about this group that's really large in acral mucosal. This is called pan-negative. So these are basically tumors where we don't know what the driver is. They don't have any of these normal melanoma drivers. And so what we've done is we've really been trying to explore and figure out what's driving these pan-negative mucosal melanomas if we target this. So while some kinases like RAF get mutations, they can also pick up what's called a gene fusion, where it gets stuck to another gene and gets activated that way. And so previously we worked with this company Ignita that has a drug that targets some of these kinases involved in fusions, and we screened like 25 acral mucosal cases, and we found two of the pan-negative cases, we were able to see that we actually were finding these kinase fusions. So this top patient, it was an acral lentiginous patient. It was a gentleman that had failed a lot of lines of therapy. He went on this clinical trial to treat his ROS1 driven acral melanoma, and he had actually a really good response that lasted for about 1.5 years. And then we had this ALK fusion, this kinase fusion in a mucosal melanoma patient. So that patient was no longer alive, but she was part of our biorepository, and we had her cell line growing, and we had her model, and we put it in mice, and we treated with the ALK inhibitor, and we saw a really good response. So I think, even though these are maybe a little less frequent, overall, we're really trying to start better understanding what is the genetic landscape of these targeted therapies, and how can we better treat patients based on this. Okay, so now I'm going to switch and go over a few slides of immune therapy before ending on just a couple slides of research. Let's see. So immune therapy, what is immune checkpoint therapy? I know you probably have all heard of it. It's really become the standard of care to try this. This is really the first line care for patients that have metastatic mucosal melanoma. But I just wanted to get into a little bit of the science of what these actually are. And so here we have depicted on the top, we have a tumor cell. And on the bottom here, we have an immune cell. And you can see there's all different molecules that cause interactions between the tumor cell and the immune cell. And what happens is some of these interactions can actually make the immune cells get activated, like these two on the right, the CD28 and the T cell receptor, TCR. But other proteins expressed on the immune cell, like PD1 or CTLA4, when they get activated by the tumor cell, they put the brakes on the immune cell. And so basically they stop the immune cell from working and killing the melanoma cell. And so companies have developed these antibodies to come in and bind what we call these immune checkpoints like PD1 and CTLA4, and here are some of the drug names over here, in order to kind of take the brakes off the immune system. And actually the combination of CTLA4 and PD1 has proven to be even more effective when we combine these two together. So here's a little bit of our own data. So what are the responses in mucosal melanoma? So there's a lot of studies out there that look in certain cohorts and have looked at PD1 or CTLA4 only. However, a lot of these studies, they don't directly compare mucosal melanomas to different treatments, different treatment methods, and they don't really compare them like within the subtypes. So we've been really trying to look at our data at Colorado and really look at these curves. So what you're looking at are survival curves. So on the left, this is single agent CTLA4, in the middle is PD1, on the right combination. So CM is this dark blue, the top line. You can see it responds the best CTLA4. It has even better response to PD1, and when you combine them together, you can see we're now over 60% long-term. This is out to 10 years survival rate in cutaneous melanoma. So this is why there's been so much excitement about these immune checkpoints in cutaneous melanoma. Now, if we look at mucosal melanoma, which is down here in the orange, you can see it has a really poor response to CTLA-4. It has some improved response, some improved response to PD-1, and definitely some improved response with combination. But we're still only looking at about 30% long-term response. So that's still actually a really good, 30% is, really a good breakthrough for, for this aggressive cancer that doesn't have as many treatment options. But still, it's not where we want it to be. It's not up, it's not even near cutaneous melanoma response rates. Another issue is this combination of the two is very toxic. So what are some other things what's happening in the immune checkpoint space? So there's a new immune checkpoint identified called LAG3. And so here you can see this LAG3 is now another molecule that we have an antibody. And there's some data that shows that LAG3 combined with PD-1 also has really great efficacy and some effect in potentially mucosal melanoma. So left of this dotted line over here means in mucosal melanoma that the combination works better. But importantly, these LAG3 antibodies are not as toxic as CTLA-4. And so really the toxicity of this combination is only about the same as what you see with nivolumab alone. So also there's a couple tables here. I'm just going to kind of highlight a few things. So these are kind of some of the ongoing or completed trials of what people are trying to do. So for example, this was a trial that we had at Colorado in mucosal melanoma combining nivolumab with sort of an epigenetic modifier. So now we're talking about combining immune therapy with other types of drugs, not just other checkpoint inhibitors. There's also been some work done on combining this with anti-VEGF or VEGF receptor inhibitors. So particularly, there's an ongoing trial at Memorial Sloan Kettering by Alex Shustari, combining nivolumab, which is PD-1, with this VEGF-R receptor in mucosal melanoma patients. And there is a little bit of some signal. There was a larger trial for just all melanomas that included a subset of mucosal melanomas that had a promising response there. And then finally, here's a trial that's combining with MDM2 inhibitor. So MDM2 is an inhibitor of the tumor suppressor P53. So basically trying to activate P53. So there's lots of different combinations outside of immune checkpoints that are being tested. Then finally, I just want to talk about, in terms of immune checkpoint inhibitors, the whole adjuvant versus neoadjuvant setting. And so when we have been talking about treatment so far, this is about treating patients that have stage 4 sort of metastatic or unresectable primary disease. However, there's a whole concept now about treating patients adjuvantly or neoadjuvantly. So adjuvant therapy is when you have your surgery and you can have the whole tumor resected and you don't have disease anymore, but you still go on a therapy anyway, just to make sure if there were any cells that were still there, or any cells that escaped, that you can treat that. And so there's a number of adjuvant trials going on, looking at things like ipilimumab, the combination versus nivo, some different dosing of the combination that's not as toxic. And then there's also neoadjuvant and adjuvant trials looking at also combining these different inhibitors. So neoadjuvant is essentially when you get some treatment or a few treatments before your tumor is taken out. Because if your tumor is still there and you get an immune treatment, that can help the immune system recognize the tumor better if it's still there. So a lot of ongoing work in clinical trials in the neoadjuvant and adjuvant space, even if you have been able to get the tumor resected. Okay, so I just have a couple slides on TIL before finishing up with just a couple research slides. So TIL therapy. So what is TIL therapy? So basically, TIL therapy is when you start with number 1 over here. Your tumor is excised. They expand the lymphocytes or the immune cells that were in your tumor. They purify them, and then they infuse them back into the patient on top of getting a few infusions of IL-2. And there's some prep work. Patients have to undergo lymphodepletion first and some other things. So this is not an easy process. This is quite a complex process, but there's definitely been promise, and the response rates in mucosal melanoma seem to be fairly positive. So the company that has been doing a lot of this work is called Iovance, and they actually just finally published in this past June their mucosal melanoma cohort within the clinical trial that they ran. And so basically they had a total of 12 patients, and they found 6 patients had a pretty much almost near complete response, or had a really strong response. So 50% overall response rate. And then let's see, when we look at this graph on the right, 4 out of those 6, or 2/3, still had a response ongoing after 24 months. So, and these were patients that were heavily pretreated and had failed immunotherapy for the most part. So I think this is really promising. It's definitely a complicated process, and it's not 100% response rate, but it definitely provides a new option, although this is still only a cohort of 12 patients. So we still have a lot of work to do understanding this. Okay, so just my last 2 or 3 slides on research and what we're trying to do. So what are some of the questions that we have as researchers? And I'd really like if anyone has topics that they would like to put in the chat or would like to share, that would also be really amazing. It's really great to get input from patients on, what do they want to see research? What do they want to know that we don't know? And so I think for me, one of the biggest questions is just what is the immune landscape of mucosal melanoma? So what do I mean by that? So basically, here's a mucosal melanoma, say a tumor, and these blue and teal circles, these are immune cells. We don't really know yet. What are the immune cells that are in these tumors? Are there immune cells in there and they're just not functional? Or are there just not immune cells in there at all? Like, are they immune cold? And so we just really don't know what the immune landscape looks like to really have an idea and to develop hypotheses of why immune treatments aren't working better. So we have a little bit of data here where you can see on the left, you have cutaneous in blue and some mucosal tumors in orange. You can see these higher dots in the orange mucosal tumors. This is the percentage of an immune suppressive type of cell called Tregs. And so we think that maybe these mucosal melanomas, they have these CD4 positive immune cells there, but they're these Treg, they're these bad immune cells. And so that's one thing that we're trying to look at in the lab is, can we treat with certain drugs and reverse and make these Tregs become functional immune cells again? I think also really important, a whole thing that is lacking in the mucosal melanoma field is really, giving consideration to the mucosal melanomas from different anatomic sites. And so here's just some of our data, and it's limited patients, but here you can see anti-PD-1 on the top and combination on the bottom. You can see the nasal melanomas are this lighter color. They seem to respond quite a bit better to anti-PD-1 compared to the other anatomic sites. So I think really giving, really pushing for researchers and clinicians to include this breakdown of anatomic sites in their work is really important, because a lot of times it's just not reported right now. Also, are there different genetic differences that could have targeted therapy? So on the left, we have head and neck, the middle anorectal, and the right vulvovaginal. And these are just some mutational profiles for some cell cycle genes on top. And I know it's really busy, but I think you can just step back and look at the anorectal tumors in the middle. They don't have very many alterations in the cell cycle or DNA damage, whereas some of these other tumors do, that we might be able to target with certain drugs. And then finally, just combination therapies. What's going to work? Is there any way to get PD-1 combined with something to work better? Or is it never going to work that well in mucosal melanoma? I don't think we know. Immune checkpoints plus targeted therapies, and finally targeted therapy combinations. I just want to start now with a little bit of like research and tools. And so I think one of the fundamental tools is really patient samples. And so there's a few, a lot of the main centers around the country have these biorepositories where we're trying to collect these samples, but it's really hard because accrual in mucosal melanoma ends up being pretty low. So I just want to highlight, back in 2005 at CU, Dr. Bill Robinson established our melanoma biorepository. And so for 20 years, we've been collecting samples and making models. And we've been able to actually share some of these specimens with other groups. It's really hard sometimes to share these patient samples between universities, but biorepositories like this are a really important key. So if you have the opportunity to share your tissue with the biorepository, that's really, really helpful. Also, preclinical models. So how do we actually study how treatments work? So mouse models are a really big part of what we do, and we can actually take a human tumor and we can grow it in mice, but these mice have to have an immune compromised system in order to be able to accept the human cells. So that's not a very good model to actually study the immune responses. However, we can actually take mice, we can irradiate them and use cord blood and sort of generate these humanized mice and put our human tumors in there. And so, for example, on the left, this is a tumor that we put in a humanized mice that we treated with black, which is the vehicle, or we treated with nivolumab in the blue line. And this was a nasal melanoma, which we find respond better, and we do see a response. Whereas the vulvovaginal tumor that we put into these humanized mice wasn't as sensitive. So we think this is a kind of a tool that we can really try and use to study immune responses. Also, in mice, a lot of times the tumors just get put under the skin because that's easy, but that's not where these tumors occur in mucosal melanoma patients. So we're actually working on developing mouse models. So here's an example of our rectum model. So we actually take these tumor cells and we inject it into the rectum of the mice. And you can see over time, this is day one, and you can see over about 30, 50 days, we can actually monitor these tumors growing. So these cells are labeled so that we can see them with imaging. So we're really trying to develop better mouse models to recapitulate mucosal melanoma sites. And finally, an interesting opportunity is that in dogs, actually, a lot of dogs get oral mucosal melanoma. And so we have a question of, could we use dogs? How similar is their melanoma to human mucosal melanoma? And can we do clinical trials in dogs? And can some of these treatments, can we study these in dogs and then translate that to patients? But in conclusion, mucosal melanoma is a cancer that develops from melanocytes really located in any mucosal tissue throughout the body. There are some effective targeted therapies based on the genetic alterations like KIT and kinase fusions, but really these new RAS multi-on inhibitors to target RAS would be a really big breakthrough, but they're still pretty early on in development, but there's definitely a lot of promise there. So immune checkpoint inhibitors are effective in mucosal melanoma, but only a subset patients, so we really don't know why. So we really need to understand more about the basic immunology of these to come up with some better ideas as to what we could do to improve this. Given its rarity, patient tissue samples are scarce and preclinical models are lacking compared to cutaneous melanoma, so we're really trying to drive this. And then finally, the Melanoma Research Foundation and other foundations are working really hard to sort of build this mucosal melanoma community to drive collaboration and progress for mucosal melanoma. So really, thanks to the MRF and others for dedicating your efforts into advancing our knowledge on the rare melanoma.
All right. Thank you so much, Dr. Couts, for
Sorry,
sharing
I
those.
probably kind of went a little long. That was a lot more than I thought.
That's
But
okay. It was extremely comprehensive. I think, you managed to make something very complex make a little bit of sense, so thank you so much for that. All right, so now I'm transitioning over to Toni English, and I have the honor to introduce her tonight. Toni is a stage 4 mucosal melanoma survivor and passionate patient advocate. Diagnosed in 2015, Toni participated in a clinical trial for TIL therapy, and because of that treatment, remains cancer-free today. Since her recovery, Toni has dedicated herself to supporting others impacted by mucosal melanoma. She is a huge leader in the Mucosal Melanoma Warriors Foundation, where she works to build community, raise awareness, and advocate for continued research into this rare disease. Toni, thank you so much for being here, and take it away.
Thank you, Caroline. You've said it all. I guess I can just go ahead and move on. But thank you for that introduction. I appreciate it. And thank you to Dr. Couts. I want you to know on behalf of the mucosal melanoma community how grateful we are that you are focusing on our rare cancer. We have waited and wished for this for so many years, and so we're delighted that your interest is going there. So thank you on behalf of all the others. As I was introduced, I was diagnosed in 2015 with a stage 4 sinonasal mucosal melanoma. By the time I had the surgery for it, it was already spreading through the entire area of my sinus, and I could see it coming out of my nose. And when I went in to finally meet with the surgeon, talk about what we were going to do, he said, well, we're going to take all of it out. And I did not realize that he meant laparoscopically. There was not a single stitch or scar. Afterwards, everything was completely removed. Followed up with some radiation, which was standard care, and then sent home cancer-free and told to have a good life and work on recovery, get healthy, and have a good time. I went through a series of a year's worth of routine scans, checkups, and exactly 1 year after I had finished the radiation, the scan showed I had metastases, quite a spread of metastases. Had 3 brain mets, both lungs had several tumors, and the right kidney had a tumor. So it began the journey of immunotherapy. I didn't have any genetic markers to give them any idea where to start, so we just went with the standard single agent and went through several treatments of that, and no response. Tumors were still growing. And so went to the next step, the dual immunotherapy. Still no response, tumors growing, and that caused such toxicity, and I went sepsis. Spent some time in the hospital recovering from that, getting my strength and health back up. Went back into my doctor and sat down and said, well, we're pretty much done everything we can, haven't we? And he said, well, not really. He said, there's just been a new clinical trial offered here to our cancer center. We have 4 patient slots. Would you like to have one? And I said, absolutely, I'll take it. So we started the process of preparing to see if I qualified and to do all the prep work for it. And this was in 2017. And by the time we got everything ready and my TIL therapy was what they were going to use for me, they sent my tissue off, sent it back. Everything was in line, ready to go. And I received TIL therapy on April 2nd of 2018. And 6 months later, all of my cancer was gone. There was nothing left, and I was one of those considered complete response in the clinical trial. So I continue to go back and get treatments and or checkups and scans and blood work and all the routine things that are done and remain cancer free. And so that's 7 years now out that without any indication of returning. So with that, along that journey is where I found the Mucosal Melanoma Warrior community and began meeting and talking to other people who were struggling and going through the same things. A social media page brought all of us together to start with. We started sharing our stories, started asking questions because nobody else could answer them, but we found that our answers were right here in front of us. So we continued to chat and visit, and then it was one of the nicest ladies in our group, bless her heart, she did not survive, but while she was an active member of our community, she felt like starting a Zoom call would be better than just reading posts on a page. So she just started a Zoom call and announced to everybody, if you want to join, this is when we're meeting. And a small handful of people joined. And it got bigger and it got bigger and it got bigger. And it became a very important element of our community. And as our community grew, it became international. There were mucosal melanoma patients from other parts of the world that were finding us, and they were connecting, and they were really excited about it because even in the foreign countries, they were more isolated and feeling alone than we were. We've had some mucosal patients in countries where they were the only case the doctors had ever seen. And so as we built our community and we got stronger and our members grew bigger, the Zoom calls became a challenge because of the time zones around the world. Everybody wanted to join. So we had to figure out, calculate how we could do this. And so currently we do 2 weekly Zoom calls so that we can reach internationally and allow other mucosal melanoma warriors to connect with each other, to bring their stories, to bring their questions, to share their journeys, what they're learning, what they're going through. And the reward for that is something that's difficult to explain. These are the most precious people that come and share something they won't talk to other people about, something they don't have anybody else to talk about. So it's really been a special joy to be a part of that. And I have found that my joy is giving back, being able to use my survivorship to be an advocate and to be a mentor, to be able to work with others and help them find their answers that they need, find their connection for friendship, support, to help caregivers learn how they can be a good support, what kind of tools and resources they need. And so this group is a real special community now. We're very proud of what we have created. We're very proud of how big our organization has become. And many of our warriors are seeing amazing successes in their treatments, where the very early days of this little small group, there wasn't much survivorship, and that was always hard. But because of the TIL therapy, because of the checkpoint inhibitor therapies, all the new research that's going on, our warriors are finding ways to survive longer, have better survivorship. And so now we're beginning to shift our whole concept into survivorship instead of just looking at them and saying, well, how long is this treatment going to help you live a few more months? We're going to start talking about survivorship from the very beginning. We want everybody to have an attitude that whatever you're going to do is going to lead to survivorship. And we want our doctors and our cancer teams to look at us that way too. Not look at us as a statistic that's got 12 months or 24 months of survivorship left, but to look at us as pushing through and surviving with the treatments that are available. And so we just enjoy having the opportunity to spend time together, to visit. One of the best things that's happened to us lately is that warriors are beginning to connect with each other in person. They're meeting up at the cancer centers if they share a common doctor, if they're traveling, if they're on vacation. They're connecting with one another. I had a surprise phone call a year ago from a warrior in Denmark who happened to be having a vacation near me, and just out of the blue picked up the phone and called me, and she said, "I'd like to stop by and see you." And things like that just don't happen every day. So special things are happening among our warriors. I'm really proud of them, how hard they all work to support one another. And we are so excited that Dr. Couts is going to take on our warriors and help us find the answers we need for finding a cure. So thank you.
I'm talking away over here. I was muted. But thank you so much, Toni, for sharing your story and what a profound advocate you are for this community. So thank you for the work that you do. And I want to invite Kasey back into our space, Dr. Couts. I know you are in the process of answering a lot of our Q&A that are coming in, so thank you for doing that. But just to kind of open up one quick question to the group here that I see in our Q&A bubble is, do researchers work together internationally to get more mucosal samples or shared data with each other?
Mm-hmm.
So I don't know if Dr. Couts, if you have.
Sorry, can you repeat that just one more time? I just finishing this one.
Sure, I know you're answering all these questions live. Do researchers work together internationally to get more mucosal samples or shared data with each other?
You know, we're trying really hard, and so there's a whole question about mucosal melanomas arising in like the Chinese and Asian population. Is that similar to Caucasian? What are the differences? But it's so challenging sharing tumor actual patient samples from one institution to the next is challenging, and then you try and factor in international sharing and export law and everything, and so it's super hard to share samples not only within the country but then also internationally. And so I think some of the initiatives now are to really just collaborate with one another and analyze our samples kind of in similar ways so that we can then share the data, right? Because it's easy to share data. Look, we have the internet, we have AI, we have databases, you know, there's so much power. And so I think, you know, really just trying to, you know, everyone sort of kind of streamline and try and standardize how we're doing different types of analyses so that we could then create a combined database to really get the number of samples we need. Because right now there's just too many, it's just too difficult to really to send samples. You know, we've sent some DNA to like researchers in Australia for acral mucosal tumors. Like I send our cell line models. So like our cell lines and PDX models, we've shipped those to the UK, to Spain. So we can share models and we can share maybe like derivatives, but actual like sharing of the patient tumors is really challenging. And so there's definitely an international effort. I think there's a lot of interesting questions about, you know, mucosal melanoma across these different ethnicities and different races. So yeah, so it's definitely a major barrier, but I think data sharing is going to be where it's really going to start being more fruitful.
Thank you so much for that. I think that's a great answer and a great question. And, you know, I think that's why we try to engage in spaces like this to collaborate with one another and to hear the efforts that are happening behind the scenes that I think sometimes as a patient we don't, or just, you know, people on the street, we don't always see what's going on behind the scene with researchers and, you know, clinicians. So thank you for for sharing that. And I know we're coming to time here, so I wanna wrap it up. But please also know that if any other questions come up, you're always welcome to email us, and we'll get that over to Dr. Couts. But I want to, as I said, wrap it up. And again, thank you so much to Dr. Kasey Couts and Toni English for sharing their expertise and experience with us. We're grateful for the insights and hope that you brought to this discussion. So thank you for being here. And thank you to everyone who joined us this evening. Whether you asked a question, listened in, or plan to share what you've learned, your participation helps strengthen the mucosal melanoma community. And before you go, please take a moment to complete that survey that's going to pop up at the end of tonight's webinar. Your feedback really helps us to continue to improve and grow these programs. A recording of tonight's webinar will be available on our YouTube channel soon. It takes about a week or two, and we'll also send that by link so you can, through an email, so you can revisit it or share it at any time. And again, to learn more about upcoming events, educational materials, and advocacy opportunities, please visit themelanoma.org. And again, if you have any follow-up questions, shoot us an email at education@melanoma.org. And we hope you will join us for future Ask the Experts sessions. And until then, thank you all so much, and please take good care. And again, thank you for being here tonight for this really wonderful discussion. Thank you all so much.
Thank you.